Hello, I'm John Heritage, Senior Lecturer in Bacteriology at the University of Leeds. Today I thought I'd like to show you how we visualise bacteria, which are very, very small and require a microscope to have a look at. And they're also not coloured, so we have to colour them up. And to do this, we're going to use what's known as the gram stain. First of all, we need to put a little drop of water onto a slide, making sure that we use aseptic technique. So notice that I've flamed the top of the bottle and I've put the lid back on. And a small drop in the centre of the slide that we're going to inoculate. We then take a very tiny amount of bacteria from a culture and spread it out into the drop of water. It's very important that you don't take too many bacteria and that you spread them out over a wide area. This is probably the most boring bit of a gram film because you need to make sure that the water in which they're suspended has completely dissipated and you don't want too many bacteria clumping up. I tend to use the area of about a postage stamp. That works pretty well, but they must be really dry before we proceed to the next step, which is to fix them onto the slide. If you're getting a bit bored, you can hold them in the top end of a Bunsen burner flame. That heats up, but not too harshly, the bacteria. But if you don't make sure that at this step they are dried out, then what will happen is when you heat fix them, the cells will boil onto the slide and they'll become disrupted. So I'm afraid this is terribly boring, and what you really want is a potter's wheel or a kitten playing with a ball of string. Short of that, you'll have to do with me waiting for the bacteria to dry. They've now dried. So that loop needs sterilisation. To sterilise it, you put it in the hottest part of the flame, heat it to red heat, and then place it on the side. And then you heat fix the slide by passing it once, twice, 3 times through the hot part of the bacteria. We're now going to move over and stain these bacteria. So we'll move over to the sink here, and I'll make sure that the water is running. We'll need that later on. The stain that we're going to use is named after Hans Christian Gram, a Danish bacteriologist who developed the stain in 1884, and despite the fact that we've had it for over 100 years, we still don't know how it works. The first step is to flood the film with oxalate crystal violet. This is a violet coloured dye that will stick to everything that's on the slide. We leave it for about a minute, but it's not critical, so we'll wash it off. So the only critical bit of the gram stain is the decolorization. To do this, you wash the iodine off, add some acetone, and wash it off immediately. At that point, the gram-negative bacteria have lost their colour, and so they need to be counterstained with a red dye. Just flood the slide now with a red dye. The gram-positive bacteria will remain blue-black, and the gram-negative bacteria will become red. And that's really all there is to staining a gram film. So you wash the counterstain off, tip off the excess water, get some blotting paper, and blot the slide dry. That's now ready for visualization. Okay, so we've now stained our bacteria, but before we're going to look at them using this microscope, we want to make sure it's set up properly. And to do that, you want an image that's really obvious. Now, in the past, we've told students to use crosses, but they're symmetrical. So what I tend to do is use something that's a bit asymmetrical to focus on. So you've got your image, you place it on the microscope stage, raise it as far as it will go using the coarse focus knob here, and then looking down, you lower using the coarse focus and then adjust using the fine focus. If your eyes don't focus equally, these microscopes are set up so that you can accommodate for this. So what you need to do is shut your left eye and fine focus with the fine focus control on the instrument. You then shut your right eye and you use the milled collar on the eyepiece to make sure that the other eyepiece is in focus. So everything is in nice focus. You've got the image in focus. The next thing to do is to make sure that the light source down here focuses on that image point. So to do that, you close this iris down and you change the position of the set of lenses underneath using the condenser control, which is hidden at the back here. Once you've got a nice crisp image of the iris, you then open it out slightly and you make sure your light is centered by using these two screws here, and then you've focused the image, you've focused the light on the image, and you've made sure that the light is going in a straight line through the image. At that point, you can open this iris fully, take an eyepiece out and adjust the aperture iris so that you have about 80% of the field illuminated. And that will give you the best resolution. So you should now have a nice crisp image and you're ready to look at your bacteria. So you can take this slide out, pop your bacterial slide in, and bacteria are so small that you really must put some oil on the slide so that they can be visualized. So you move the objectives out of the way, put a drop of oil on the slide, and then you move the oil objective into the oil drop. Oil has a higher refractive index than air, and that means that you can resolve smaller particles. And at that point, you should get a very nice image of your bacteria.